Welcome to springlib.
Hello. Here we have to calculate several values of several limits, and in order to make it efficient and due to the size of the question, I decided to attach the already performed solutions. And now I'm going to walk you through these solutions. So for questions 2, 3, and 4, we'll be using L'Hopital's rule, which states that the limit of the uncertain value, which is either 0, 0 or infinity over infinity, can be calculated as a limit of the derivatives of the numerator and denominator if several conditions are met. The conditions are listed on the screen, so both limits of denominator and numerator have to be 0. Then the derivative of the denominator has to be non-zero for all x from the interval of around the special point, and in our case, the special point is 0. And thirdly, both the limit of the ratio of the derivatives has to exist. The first question is limit of tangent of x over x when x approaches 0. So the derivative of the numerator is 1 over cosine squared x, and the derivative of the denominator is 1. Therefore, this limit equals to the limit of 1 over cosine squared x when x approaches 0, which is 1, because square cosine of 0 is 1. The next question is sine of 2x, limit of sine of 2x over sine of 3x. So the derivative of the numerator is 2 cosine 2x, and the derivative of the denominator is 3 cosine 3x. Both are non-zero when x is 0. So therefore, this limit equals to the limit of the cosine of 2x over cosine of 3x multiplied by 2/3. So both of these cosines are 0 when x is 0. Therefore, this ratio equals to 2/3. And this is the answer to this question. So for the next one, limit of 1 minus cosine of 2x over x squared, we have to apply the L'Hopital rule twice. So the first application of L'Hopital rule yields to limit of sine of 2x over x when x approaches 0, and now we have to apply the L'Hopital rule again. So the derivative of the numerator in this case is 2 multiplied by cosine 2x, and the derivative of the denominator is 1. So therefore, this limit equals to the limit of 2 cosine of 2x over 1 when x approaches 0. So, and it equals to 2 because cosine of 2x when x is 0 is 1. And the last question is limit of sine x over tangent x. So here we can solve this problem straightforwardly. So tangent x is sine x over cosine x. Therefore, this fraction, sine x over tangent x, transforms to cosine x. And the limit of cosine x when x approaches 0 is 1.